Good afternoon, thanks for joining. This topic will introduce the idea of a decision input flow, and that is the stereotype that you see on this object flow in this activity diagram. If you are new to using activity diagrams, you may not have known that this is actually something that you can already utilize within Cameo, and you may have the question of what does that actually mean? And really what that means is an object flow will be passed to a decision node that will be used to make the decision for which path that control token should take on the outflowing guard. So a few things to take note of here. There's an output pin coming out of this activity, and that output pin is named bit passed. The output pin is also typed as a Boolean, meaning that the value that actually comes out of this pin will either be true or the value will be false. When you get to the decision node, the decision will actually look at the guard conditions, and in this case we're saying if bit passed is equal to true, then take this path. Bit passed is what is actually coming out of here as either true or false. So we're evaluating the name of an object called bit passed and then its value being either true or false. And of course, in JavaScript, you can always use a guard of lowercase e else, and that will take the path that is not net. Getting back to the decision input flow, if you right-click on an object flow, you have the option of checking this option for decision input flow. Now, when you do that, according to UML, since this is actually a carryover from UML, you also have to add a control flow that comes from that action to the decision. Funny as it may be, however, if you don't use the decision input flow, then you don't need the additional control flow. You could actually have a decision that would look like this, and in a simulation, this would actually execute, and that value would still be passed to the decision. Depending on whether or not that was true or false, would determine which one of these outgoing control flows will receive a token. The idea that you need to have a decision input flow is not necessarily the case. However, if you do add this additional input or additional information, then if you run a simulation, you will actually time out your simulation unless you add the complementary control flow. So that's something to keep in mind. But the other question is, how is this really used? And in this case, notice that this action is called perform bit, or it's typed by the behavior that is another activity called perform bit. And that is what you're looking at here, is actually the called behavior, because this is a call behavior action, and the action is calling the behavior of another activity. That other activity is what you're looking into here. So what's neat about this is if you run a simulation, you'll actually delve into this action or the called behavior. And then when you get into this, notice there's some other things that are being evaluated here, such as board temperature. And maybe that was a printed control board that you're monitoring the temperature of, and that's something that you're looking at in a built-in test. And in this case, we're saying that if that temperature is greater than or equal to 100, then take this path. And what that'll actually do is set this value property, this called bit passed, to false. And it'll actually pass a value of bit passed false to this merge node in this case, and out of this activity parameter node. And that will pop out right here. So we'll actually be passing a value of false. And in that case, you'd actually take this path and perform a bit check again, or perform bit built-in test again. However, if the opposite is true, if the board temperature is less than that value, then bit passed will actually receive a value of true. That value of true will take this path of this object flow and the output out of this activity parameter node, And in this case, it's the action output pin. And then that will be passed to the decision, which will then cause it to take this path. So let's see what that looks like in action when we run this simulation. Now notice I'm going to run this with context. And what that means is we can access the value properties of the block that's executing the activity or that owns this activity. So because this activity is actually owned by another block, I believe it's this block, we can access this value property that's called board temperature. And as you notice, we have a default value of 150. It also has this value property called bit passed. So let's try running this from this activity diagram with context, and we'll see what this looks like. So we'll slow this down. So notice we've delved into this behavior with the call behavior action, passing value of false because we're over 100. That value will actually pop out here. Notice false is coming out, and because it's false, it's not bit passed, so it's else, and it takes this path again. Now, if we change this value to something that would be less than 100, when this makes its loop back around, you'll see that the value of true will be evaluated, and then we should take this output path of bit passed. So this loop around, we're sending the value of true here. That's what should output. And now we have true, and we get a bit passed. So that is a way that you can use a decision input flow or evaluate real data in an activity, which is neat because then you can set up your model in a way that it'll work for you. And it really helps you build out your data model because now you understand there's actually something that can be evaluated, and you can do a real evaluation of that and have your model take different paths and make different decisions based on those, whether or not they're not necessarily just true or false. That doesn't have to be a Boolean. It could be any type of value or value type. It could be a real number. It could be an integer, or even something even more complex than that, like a block, and that block could have other values embedded in it. So there's a lot of different ways you could use this. But getting back to this idea of the decision input flow, let's get rid of that this time, and let's also get rid of this control flow and just watch what happens if we run this without the decision input flow. So casting a value of false should arrive at this decision. And that's the path we're taking. So let's change this to something else now. And it looks like our value of 99 was evaluated to be less than 100. And now that is being passed. And there you have it. So at the end of the day, if you're running simulations, you don't necessarily need to have that decision input flow going to your decisions, but it can be a nice thing to add. That way you're giving your reader a bit of information and saying, hey, there's something coming out of here that will be used to actually make a decision, and this will be that decision point. But then the one thing that you need to keep in mind, if you do use the decision input flow, is that you need to add the complementary control flow, or else that will not work. If you have any questions on this, please feel free to reach out. Thanks a lot.